And another quarantine day in the Cornell household. Today's a big Spanish day with the kids. Still not liking it. Not as nice out, so they are inside a lot more than normal. That's not fun either. So hopefully it gets a little bit warmer, a little bit nicer, so we can get back outside. Hope everybody else is doing well. Hope everybody's staying away from everybody so that this thing can stop and we can get back to school. Jose, do you go to every one of the lives? You do know that you only have to go to the Trig lives, right? And I hope you ended up finally getting your McDonald's and you're finally at home now. Hello, Carlos. So if you guys did the notes from yesterday of 12-3, then you went over the whole and or probability. Okay, or meaning we don't care which one you pick, so you just kind of put everyone in each one of whatever elements they're talking about together in one, and is the intersection or what's in common between all of them. Okay, so we'll go through these. If you had any questions for the notes, let me know. Otherwise, I'm going to jump right into exercise 7, which was not in the video, but it was just like a little bit extra. Oh, thanks, Jose. Now, if only you came to school as much as you came to these streams, then you'd really be good to go. All right. So, you can't answer exercise 7 if you do not know or play cards in any way. Okay, so if I give you a quick rundown of cards, there are 52 cards in a deck. Okay. Well, that's good. There are 26 cards that are black. And then there are 26 cards that are red. Oh, that's not good. Okay. 26 red cards. Now, from there, if you break up the red cards in half, there's going to be 13 and 13. 13 of them will be hearts. 13 of them will be diamonds. And if you did the same thing with the black cards, okay, 13 of them will be clubs and 13 of them will be spades. Okay, and this here is what makes up the 4. Okay, 4, 1, 2, 3, 4 of each card. And that's ace, king, queen, jack, and then 10 to 2. So that's kind of the rundown. That's how they break up all the cards. So if I wanted to find the probability of getting a heart, you'd have to know how many hearts are in a deck. And we just said that there are 13 out of 52 total cards. And that's the probability there. And again, if you simplified it, it ends up being 1/4. Okay, then they want to know how many aces. Okay, aces, there are 4 of them out of the total of 52. Okay, and then again, one thing I don't know if I said this the other day, if you go to cimath.com, there's a link right under the YouTube, and you can kind of see there's an online calculator you can go to if you don't have yours, and then you can, if you needed to, and there you go, if you're going to simplify 1 out of 13. Okay, a black 3, so if I come down here, remember, okay, so if we're looking at 3s, these are all 3. Well, 2 of them are red, and so that means just 2 of them are going to be black. So this one, a black 3, there's going to be 2 out of the 52, and then that would simplify to 1 out of 26. All right, so now here goes that or probability, okay? So a red or a 7. So the probability of getting a red card would be 26 out of 52. The probability of getting a 7 would be 4 out of 52. Now, if you remember, for OR probability, you have to kind of take out the ones that get repeated, because isn't it true that you have cards that are red and a 7? So you'd have to kind of subtract out the 2 cards that are red and a 7. So you do 26 plus 4, which is 30, and 30 minus 2, so that's 28 out of 52. Okay. A diamond or a jack. Okay, so if you came down here, 13 of the cards are diamonds. 4 of the cards are jacks. Now the question is, how many of the cards are jack and diamonds? Well, there are 4 jacks, and how many of these jacks have a diamond on it? And that would be 1 out of the 52. So then this is going to give you 16 out of 52 cards. And then the last one, not either a king or a queen. Okay, so you want not either a king or a queen. So you want anybody else. So there are 4 of these and 4 of these. That's a total of 8 total cards that you do not want, right? You do not want these cards. And so how many cards are left? There would be 44 cards left out of a total of 52. Okay, so that's just kind of a rundown if you're doing cards. If you're ever going to go to Vegas, this is kind of how they look at it. Okay, and the really good people can count the cards and know exactly what they're doing. But that's illegal, so we won't go there. But we will go through the homework questions here of the stuff that you looked at last night. So again, if you have any questions as we're going, feel free to ask. So the first one, union, that's or. So if you look at what's in A, it's 3, 5, 7, 9, 11, and 13. 3, 5, 7, 9, 11, and 13. Or B, so we can pick out all of the B's. So that's a 1. I'm not going to write the 5 because I already have the 5. I'm not going to write 9 because I already have the 9. I'm not going to write 13 because I already have the 13. And then so the only one left is 17. So those are basically putting this house and this house, these 2 people into one house. But again, don't repeat anybody. Intersection, that's in common. So all I want to know here is what is in common between A and B. So we were just going to look at that before. They both have a 5, they both have a 9, and they both have a 13. So that's the intersection. Okay. And now part 2 wants us to kind of prove, call this like the formula for OR probability. And OR probability says that you take everyone in A, add it to everyone in B, and then again subtract out who's in common. So if we're going to take and rewrite everyone who's in A, which would be 3, 5, 7, 9, 11, and 13. And then you're going to add it to who's in B, which I cannot see, which is 1, 5, 9, 13, and 17. Okay, so this is everyone. And then you're going to subtract out, again, this is saying who's in common. So who's in common, we said was 5, 9, and 13. So if you cross off 5, if you cross off a 9, and you cross off a 13, because you're subtracting them out, this is what's left. 3, 5, 7, 9, 11, 13, 1, and 17. And that's exactly what we wrote up here. So this is really what we're looking at today. This is what you want to memorize, or probability. Add your 2 elements, subtract it out. All right, so now here are some questions about how they could ask it to you. So Red Hook High School has 480 freshmen. Of those freshmen, 333 take algebra, 306 take biology, and 188 take both algebra and biology. Which of the following represents the number of freshmen who take at least one of these 2 classes? So they could take what they're saying, at least one of these 2. They're just saying algebra or biology. Okay, that's what they're asking here. And now to do that, I would say, well, take the elements in A, those in algebra, add that to the freshmen that are in biology, and subtract that from the freshmen that are in algebra and biology. Well, here there was 333, here there was 306, and in both was 188. You do your math and you're going to have 451. Yeah, 451. So those are the students that are in either algebra or biology. Okay. So just kind of get used to the different ways that they could ask it to you. Okay. Same exact question, but now you're kind of looking at it in a Venn diagram model. Okay. So Eve was doing a science fair project. She found that of the 30 students, so that means that your sample space has 30 students in there. 15 of them have brown hair, 17 of them have blue eyes, and 6 have neither. Now it says determine the number of students who have brown and blue eyes. So that's going to go right here in X. Now notice that I wrote the 15 out here and the 17 over here. Those are not the numbers that go here, because if I'm writing them here, that means that this student only has brown hair. That means that these students only have blue eyes. The 15 and the 17 take into account the people that have both brown hair and blue eyes. So in this question, again, it's kind of saying it's an OR probability. The probability of, so if I took the 15, the 17, and the 6 and added them up, there are 38, okay? Are there 38 students in this question? No, there are only 30. So how many am I missing? I'm missing 8. Who are the missing people? Those are the people that are both. Right there, 8. Now, if I wanted to, I could always do the math. Remember, 15 minus 8, 7 can go here. 17 minus 8, and then the 9 could go there. So that would say 7 students only had brown hair, 9 students only had blue eyes, and then 8 would have brown hair and blue eyes, and 6 are neither. And that would all give you my 30. Okay, here we go. A standard 6-sided die is rolled and its outcome is noted. Which of the following is the probability that the outcome was less than 3 or even? Okay, so then probability less than 3 or even. Well, less than 3, 6-sided die, you can have a 1, 2, 3, 4, 5, or 6. Who's less than 3? 1 and 2. So you have 2 out of 6. Or we add even. Who is even? 2 is, 4 is, and 6 is. So that's 3 out of a total of 6 sides. But remember, with OR, you have to subtract the end, right? So are there any numbers that are less than 3 and even? Yep, the 2 is less than 3 and even. So that's 1 out of 6. 2 plus 3 is 5. 5 minus 1 is 4. So that's 4 out of 6. That simplifies to 2 out of 3. Okay. So that's there. 6. Okay, historically on a given day at the beginning of March in upstate New York has an 18% chance of snow, 12% chance of rain, 4% it will rain and snow on a day. Then which of the following represents the probability that it would that a day in early March would have either rain or snow? Okay, probability of rain or snow, or is probability of rain plus the probability of snow minus the probability of rain and snow. They told me that rain, now I have to write 0.18 because look at our answers here, and I'm getting that by doing 18 out of 100. Okay. Probability of snow is 0.12, and then subtract the rain and the snow, and that's not 0.4 but 0.04. Okay, so be careful when you're doing 4. Okay, and then that is going to be 0.26. Okay, 17, being able to read a table. So up here we're talking about hair color. So these are all people that have black hair, 0.45. Hair color blonde, these are all my people with blonde hair. These are all the people with red hair. Here's my total. And then you can work this way to see eye color. So here are all the people with blue. Here are the people all with brown eyes. Here are all my people with green eyes. And then you can do kind of your end. How many of them are blonde and blue eyes? Well, you go here, and that's how you kind of figure out the 0.2. So a student had black hair. We want all of them. That's 0.45. A student has blue eyes. Okay, so that's all of the students. Total was 0.4. The student has brown eyes and black hair. So if I say brown eyes here, and then black hair here, my intersection was right there, and that's at 0.25. Okay, so there's your end probability or end question there. Okay, a student has blonde eyes or blonde hair. Okay, so here's that question again. So it's or. So first, tell me all my blue eyes. Well, all my blue eyes are 0.40. Then tell me all of my blonde hair. Okay, so where are all my blondes here? They are 0.35. Now, because it's or, you got to subtract the blue eyes and the blonde hair, which was 0.20. So you subtract out that end, and then you're going to have there 0.55. Okay, and then here it is, same question again, or a similar question, but now we're going to have black hair with blue eyes. Black hair with blue eyes. So here is black hair. Black hair was 0.45. Blue eyes, right there at 0.40. Now, black hair and blue eyes. Black hair and blue eyes, that's my intersection, that's 0.15. Right there. Okay, and then that's going to be 0.70. Okay, so it seems like we're doing pretty good. Not too many questions coming in. And number 8, okay, a recent survey of Arlington High School 11th graders, students found that 56% were female. So 56% equals a female. 58% like math. And that one goes out to Jose since he joins every live. And 76% of all students are either female or like math. So 76% are female or like math. Okay, so that's kind of how it looks with that one. So then they says, what percent of 11th graders were female students who liked math as their favorite subject? Female students who like math and, okay, this is an and, so that you want to be female. So the question is female and like math. It's kind of a backwards one. So if you're looking at the or probability, okay, you're looking at or probability because that's kind of the only area we know about where we're using that. So probability of female or liking math, right? That they told me was 76%. Okay, they said that part. Then, well, how many of them are female? They told me that. That was 0.56. How many of them liked math? They told me that. That was 0.58. Then remember, for the formula, you have to subtract out the end. You have to subtract out the end. So you're going to subtract out the x. Just pretend like you're in 9th grade algebra again, okay? And just do the math. Okay, that's going to be 1.14, 0.76, minus 1.14, and that's going to be negative 0.38, divide by your negative. So x equals 0.38, and then remember, times it by 100 to get your percent back. And there you go. That was all of the work for 12-3. And if you're doing good so far, keep it up. Remember, cimath.com is where you'll be able to find everything. Watch 12-4. We'll go over that again tomorrow, probably around the same time. If other times work better and consensus says that I can get more people to come to live at 5 or 6 or 7, we can do that. Just leave a comment down below, let your friends know, hit subscribe. Have a safe